Hey guys, welcome to another video of statistics, and the objective of this video is to go through the 5-number summary of a specified set, and then afterwards we're going to represent these 5 numbers by using something called a box plot. So let's go through the 5-number summary. So firstly, you're being given a set of data, and also you're given a sample size, which will assign this number to n. So the sample size basically is the amount of values that are in your data. So back to our example of people in class 1D. So we had 10 people that were males, which we assigned x1 to, and there were 6 people that were females, which we assigned x2 to. So we're given 10 and 6 as our values, and so the amount of values that were given in our data is just 2. So therefore our sample size is just 2. So with data, especially with sets that are much more larger in size, we represent it with these 5 numbers here. So x1 is the minimum, q1 is the lower quartile, x squiggle is the median, q3 is the upper quartile, and xn is the maximum. So it's a maximum number in our data. And n is in fact our sample size, which we assigned it to. So remember, n is the amount of values that are given in our data. So let's go through our 5-number summary. So the first number that we'll go through is the minimum, which is x1. So that's normally the lowest number in the data. So one good example is, let's say for example we're given a set of data 4, 2, 1, 3. So the first thing to do is obviously to rearrange them from lowest to highest. So 1, 2, 3, 4. And so obviously here the lowest number is just 1. So we can conclude here that the minimum of this set is 1. And so that's the first number of our 5-number summary. So the next number that we're going to go through is called the median. So the median x squiggle, and some people they call it q2. So that's defined as the value such that at least half of the data are less than or equal to x squiggle, and at least half of the data are less than greater or equal than x squiggle. So a good way to think of this is, again, looking at this example. So let's say we have been given a data 1, 2, 3, 4, 5. So our sample size here is 5 because we're given 5 numbers. So we write it out, and the median is in fact the halfway line. So it's the number that is halfway in our sample set. So in this case, the middle, which is just 3. So the way that I think of median is that on the left-hand side of our median, the amount of numbers on the left-hand side should equal to the amount of numbers on the right-hand side. So for example, if our median was 3, the left-hand side of this median, the amount of numbers are just 2. There are 2 numbers. And so on our right-hand side, the amount of numbers on the right-hand side is there's also 2. So because the amount of numbers on 2 sides here, are exactly the same, which is 2, right? Therefore, x squiggle, is 3. Just because the amount of numbers on both sides are equal. So therefore, we conclude that x squiggle is 3. So that's our median. Now, if you look at a special case, so let's say you're given a data set and your sample size was a multiple of 2. So you're given this data set of 1, 2, 3, and 4. And so the sample size is 4, which is a multiple of 2. So obviously you write it out 1, 2, 3, 4. Now you can't choose 2 or 3 because let's say you choose 2, right? The left hand side of 2, there's only 1 number. The right hand side of 2, there's only 2 numbers. So numbers on both sides of 2 are not equal, and same thing with 3 here too. So what we do here is we pick up the middle 2 numbers, the middle 2 numbers of our set, and we do an average between those 2 numbers. So the average of 2 and 3 is just 2.5. So therefore our median of this sample set is just 2.5. So the next number that we're going to go through here is the lower quartile. So the lower quartile is defined as the median of the lower half of the data. So back to our example of 1, 2, 3, 4, and 5. The sample size being 5. So firstly, we have to identify what our lower half is. So our lower half is 1, 2, and 3, including our median. So that's our lower half. So once we have identified our lower half set, so 1, 2, 3, we find the median of this, which is easy, and that is just 2. Okay, so the median of lower half is just 2. So we can therefore conclude that the lower quartile is just 2. So again, with our special case, let's say you had a sample size of 4. Okay. So firstly, our lower half, right, is going to be 1 and 2. Okay. The reason why it's not 2.5, which is our median, is because 2.5 wasn't in our set of data that we were given. We're given 1, 2, 3, and 4, and 2.5 wasn't in our set. Okay. So we don't include 2.5 in our lower half. Okay, lower half set. So therefore, our lower half set is just 1 and 2. Okay, the lower half. So find the median of this lower half, okay, which is just 1.5, okay, the average of 1 and 2. So therefore, we can conclude that Q1 is equal to 1.5. Okay. So the next number we are going to go through is Q3, okay, which is the upper quartile. So firstly, the upper quartile is defined as the median of the upper half of the data. Okay, so again, we're going to identify our upper half. So back to our example of 1, 2, 3, 4, 5, our sample size being 5. Okay, so upper half is 3, 4, 5. Okay, we include the median because it's in our set. Okay, so 3, 4, and 5. That's our upper half of the sample set. So we find the median of this, okay, which is 4. Okay, so x squiggle is our median, if you remember from the beginning of the video. Okay, so that's equal to 4. So therefore, we can conclude that Q3 is equal to 4. Okay. And same thing with our special case, if our sample set is a multiple of 2, okay? So let's say, for example, you have 1, 2, 3, 4 as your sample set, and your sample size is 4. So lower half, your identifier is 3, 4, okay? So remember, 2.5 shouldn't be included in this set because it wasn't in our original big set, okay? So therefore, the median of our lower half is just 3.5, okay? And we can conclude that the quartile, the upper quartile of this set 1, 2, 3, 4, right, is 3.5. Okay, so next number that we're going to go through is called the maximum, okay, xn. So xn is the highest number in the data, okay? So for example, if we're given this set 1, 2, 3, 4, 5, okay, sample size being 5, it's obvious that the largest number, x5, okay, is 5, okay, because that's the maximum number in our set. So just to summarize our data, okay, so for example, so let's go back to our sample size of 5. So 1, 2, 3, 4, 5 being our sample set, right? So we'll write our five number summary like this, okay? So back to what we had discussed before, okay? So x1 is equal to 1, okay? The minimum was 1. Lower quartile was equal to 2, okay? Median being 3, okay? Upper quartile being 4. x5, which is our maximum, is 5, okay? So this is our 5 number summary. So there are other numbers that we have to also know, okay, using the 5 number summary. Okay, so the first number that we have to know is called the range, okay, which is determined using this formula here, xn minus x1. Remember, n is our sample size. Okay, so back to our example, right, of 1, 2, 3, 4, 5, right, sample size being 5. So our range, right, would just be x5 minus x1, okay, which we said was 5. Okay, x5 being 5, x1 was 1, so therefore 5 minus 1 is 4. So therefore our range of this set, 1, 2, 3, 4, 5, is just 4. Okay, so next number that we also know, okay, is called the interquartile range, which is the upper quartile minus the lower quartile. Okay, so Q3 minus Q1. Okay, so back to our summary here, Q3 was 4, Q1 was 2. Okay, so therefore IQR, okay, which is interquartile range, okay, that's just Q3 minus Q1, which is 4 minus 2, which is 2. So we can conclude that interquartile range of our set 1, 2, 3, 4, 5 is just 2, okay? Alright guys, I'll see you in the next video.